Okay, so using the chain survey, what we are doing, we are able to measure only the linear measurements. Okay, linear length. It's a replacement of the chain only. Okay, so now can you see the PPT? I think it's already shared.
Yes, ma'am.
Okay. So what's the difference of a theodolite from the other instruments is that theodolite it is used for measuring the angle. Okay, you can measure the horizontal angle or the vertical angle. Okay, but for chains in the chain survey you are using only the length measurement. You can measure the length by means of a chain or tape, while the angle you can measure by means of a theodolite. And in place of that, compass also is another instrument that we can measure the angle. And the compass it is usually used for finding the bearing or the direction of that line. Okay. So what do you mean by theodolite? It is used to measure the angle. Any horizontal angle or any vertical angle can be measured by means of a theodolite. Okay. And the most important thing to be remembered for the theodolite is that it is the most accurate instrument. Okay, it is having the minimum least count. It is having a least count of 20 seconds. Okay, so I think you already know what is a degree. It is already known. So the compound, the subparts of that it is minutes, and then minutes again can be divided into second also. Okay, so the angle measurement in theodolite it is like we can read the degree, how much minute and how much second. Okay, so up to seconds the value can be read from the theodolite, the angular measurement up to seconds, and that seconds it is 20 second. According to the instrument it can be 10 second also. In our lab, in our GEC lab, it's 20 second I think. Okay, so least count of theodolite it is 20 second. It is the minimum value of the angle that can be measured by means of the theodolite. Okay, and now there are different types of theodolites. There's again the electronic theodolite. Okay, so can you see this orange instrument? These are the different types of instruments. Okay, so this is the most old one and usually used one. Actually the modern instrument it is electronic type. This is the electronic type. You can read the angle directly. It's a electronic value will be recorded on that. So can you read on that scale like this? Some values it is written here, while here the difference is that values will not be written. You will have to make out from the scale what is the angle you have to measure. You have to read from that. So these are the just different types of theodolites. That's all. And now coming to the different parts of the theodolite, I think this picture is visible. So what you are seeing here this is a telescope. Okay, this is a telescope. This is the vertical circle. Vertical circle means just a circle in the vertical plane. Then there is a horizontal circle, or that is a circle in the horizontal plane. And there is a attachments, supportings like that. So the main parts are there is a telescope. Then there are the two circles, vertical circle and horizontal circle. Okay, from the horizontal circle, you can measure the horizontal angle. And from the vertical circle, you can measure the vertical angle. So along with that, there will be, can you see there is a bubble tube here. Okay, so likewise you can see on the vertical circle also, these two bubble tubes are used for leveling. At the point at which the bubble it is coming to the center, that's the point of leveled instrument. Okay, at that time we can say the theodolite it is leveled. Okay, so when you are measuring the horizontal angle, the instrument should be leveled in the horizontal direction, and in the vertical angle, to measure the vertical angle, you should check whether the vertical circle is leveled. Okay, so what are the different parts of the theodolite we have seen? There is a telescope, the two circles, then there is a leveling bubble, and now can you see the screws itself? There are three screws, foot screws. This is the first screw, second one, and there will be the third one. This is the behind. Okay, so the full theodolite will be placed on 3 screws, and we have the provision for attaching this to a tripod. And now one more thing I have to add here is that some more additional screws you can here see here. This is one screw. This is the corresponding vernier screw. Similarly, there will be 2 screws on the side also. And there is the another thing we have to note is that I told this is the horizontal circle or horizontal plate. We can say inside this there will be 2 plates. There is the upper plate and there is a lower plate. Okay, so actually in this casing, this horizontal circular casing, inside there will be 2 plates like circular plate. Okay, so on these plates some measurements will be marked similar to what you're seeing on your protractor. Because you are not able to visible because it is an online class, just I'm telling that the measurements will be marked inside and we'll have to read out what is the value correspondingly from the verniers. Okay, will be 2 verniers, A vernier and B vernier. This is one of the vernier that you're seeing, a slit like, a glass like through which we'll be viewing, and you can see the portion of the plate here. Okay. So I think for today's class, we have not got the video of measurement. From our lab, we will be collecting that and demonstrating that in the next class, I think. Okay. So just first of all, we can study what is the theodolite, what is the purpose, what are the different methods of measuring like that. And now here is the different components we can see. Mainly we can see there is a vertical axis and there is a horizontal axis. Okay, this is the horizontal axis. Okay, so this is your telescope. So perpendicular to the direction of the telescope, there is the horizontal axis. And now, what is this line? Telescope means you know it is the thing through which you will be sighting, and hence the axis through that telescope is called the line of sight. Okay, line of sight. So always the horizontal axis will be perpendicular to the line of sight, and both this scope in the horizontal direction. Okay, so these are the main parts, and here we can see that this is the leveling head. Leveling head, in that it is the 3 screws I have told already. There are 3 leveling screws. So based on these screws, you will be leveling the instrument. Okay, so these are the main components. And here just we can see this slide itself. What is meant by transiting? So here, what is written? A transit theodolite is one in which the telescope can be rotated in a vertical plane. So where is your telescope here? Or we can see the telescope here. Okay, so this is your telescope and this is the vertical circle. And this telescope it can be rotated in the vertical plane. You can imagine like a vertical plane passing through this telescope, and this telescope it can be rotated in the vertical plane. Okay, it can be rotated through 360 degree. So in such instruments, that is in the instruments in which we can give the vertical motion of the telescope, it is called transit theodolite. Okay, transit theodolite. And usually we are using the transit theodolite only. And now one more thing. So I told here telescope can be rotated vertically. Similarly, the telescope can be rotated horizontally also. Okay, it can be rotated in the clockwise or anti-clockwise direction. And now, okay. So here it is the different parts of the theodolite. When you are writing the study of the instruments of the theodolite, you will be given such a picture and you will have to copy down the picture. Okay, the different parts are here. Okay, so I think better the main parts I will be mentioning here. Here, this is your telescope. Okay, And now, this is the position of your plates, horizontal plates. Okay, so can you see a screw like this here? There will be a main screw, and along with that there will be a sub screw, that is a vernier screw also. So like this, two screws will be there, and this screws, the main function of this screw is to control the movement of the two plates. I have told there are two plates within the horizontal circle. Okay, so that plates, we can say it is the upper plate and the lower plate. Here marked number 17, it is the upper plate. Okay, so what is that? Here this is your upper plate. It's like a plate, a circular plate. When it is placed within, it is just that. Similarly, what is this? This is the lower plate. Okay, so only thing, there will be provision to move this upper plate above the lower plate. Okay, so this movement control is done by means of the screws. There is a two screws here. Here we can see there's upper clamping screw, and there is a vernier screw also. Okay. Similarly, there is a lower plate or lower clamping screw. And for controlling the movement of the vertical circle, there is a vertical clamping screw. Okay. So just we can make an idea what are the different components of this from this picture. That's all. Okay. Once the video of that from our lab is shared in the next class, probably we can study what are the different parts of the instruments. Okay. And now, again, what are the explained? I have explained before. That's all. It is repeated here. There is an upper plate and there is a lower plate. And there is a screws. There is a main clamping screw and there is the corresponding tangent screws, or it's also called the vernier screws. Okay. So what is the difference between the main screw and the tangent screw? So tangent screw, it is just for getting the minute adjustment. Actually, when the plates or when the telescope is being rotated in the horizontal and anti-clockwise direction, in the horizontal direction when it is rotated, that movement it is controlled by the main screw. Okay, and if some minute distance through which it is to be moved, in such a case, the tangential screws will be used. Okay, so that's the purpose of the tangential screw. So big angles through which it is if it is to be rotated, in such a case it is we are using the clamps, the main screws, and minute adjustment it is done by means of the tangential screws. Okay, so for the horizontal plate, the controlling screws are there. There is the main screw and the tangential screw. Similarly, for the lower plate also, there will be the screws correspondingly. Actually here you cannot see such screws in this picture. Okay, so just try to make out that different parts include the two screws, two set of screws will be there. Similarly, for doing the vertical measurement or vertical motion, it is controlled by means of again two set of screws. That is the main screw and the tangent screw will be there. Okay, and now we are told there is a bubble plate. That's a plate level for leveling the instrument. It's the plate level or plate bubble, we can say. And what is a telescope? Actually, through the telescope, we are pointing to that object on which we have to sight. That is the telescope purpose. So, you know, in the telescope, there will be the eyepiece, there will be the object lens, then crosshairs, like the different parts of the telescope. It's provided for this also. Okay. And okay, this is the vertical circle and vertical screws. Okay. So in this picture, what you're seeing, two circles. You can see two circles. Okay. This is the vertical circle. Okay. So just imagine like this circle is vertically positioned. And where is this vertical circle located? Inside the vertical plate. This is your telescope. On the side of this telescope, this vertical plate is there. We can go to the previous picture. Okay, so in this we have seen this is a telescope and this is the vertical circle. So actually this is the casing. What we are seeing from the outside, it is the casing only, case for that scale, vertical scale. Okay, vertical scale or vertical plate. So inside this, it is provided that vertical circle. Similarly, within that horizontal plate also there will be horizontal circles. Actually, two circles will be there in the horizontal direction for measuring the vernier that we can see later. So these are the main components. Okay. So here it is the horizontal circular portion. It is given here. So can you see here there is a main scale. Okay. So this is a complete circle only. This is completing for the total 360-degree. And you can see here it is varying from 0 to increasing 10, 20 like that. It is coming to 360-degree. Okay. Similarly, so actually this is a portion what we are seeing as the detailed one, the portion of the main circle. And now can you see a small circle, so a small circular portion on the side, and that is the vernier. It is a vernier scale. So the minute angles, that is approximately to 20 second or 40 second like that, you are measuring by means of this vernier scale only. Okay. So actually, from this main scale, you will be able to measure how much degrees and how much minutes. Okay, degrees and minutes you will be reading from this outer circle or the main circle, and from the inner circle, inner scale, or that is also called the vernier scale, you will be able to measure how much minutes and how much seconds. Okay, so what you're getting here? From the main scale, you have got what is degree and minute, and from the other one, minutes and second. So you can see 2 minutes are there. Okay, you will be getting the minute reading from the main scale as well as from the vernier scale. Both will be added together to get what is the total angle you have read in the degrees, minutes, how much second, like that we'll be getting. Okay, and now these are different definitions. While writing your study of the instruments, you'll be required to write this also. What do you mean by phase right? What do you mean by phase left? Telescope normal, telescope inverted, write that. So actually, phase right means when the vertical circle is on the right of the observer. Okay, just that picture. Okay. So here this is your vertical circle, and from where you will be sighting, the observer will be standing at this position near the eyepiece. Here there is the eyepiece and here there is the objective of your telescope. Okay, so through this you will be sighting. So the observer will be standing near this eyepiece and viewing through this. You will be there will be some object or some ranging rod like that to which you will have to sight. Okay. So here we can see in this picture, this vertical circle, it is on the right or on the left. With respect to this picture, when the observer is standing at here, this vertical circle will be on the left. So that means it is a face left. Okay. When the vertical circle is on the left of the observer, that is called face left. And face right means the other. Face right means vertical circle is towards the right of the observer. Okay. So actually, while measuring an angle, you'll have to get both the readings. In the face right, what is the angle? Similarly, in the face left, what is the angle? Actually, in this picture, it is written. I don't think you'll be able to make it from this. And now, next, we can see what is a telescope normal and telescope inverted. So in the usual position, how the telescope will be, it is the normal position. And when it is inverted, telescope can be inverted in the just by tilting. We are told what is transiting. So that is a portion of the inversion only. Okay. So when the telescope is inverted, that is the inverted telescope position. So we are saying what is phase left, phase right, telescope, two positions, normal and inverted. And another thing is that the telescope, it can be revolved, it can be rotated in the complete 360 degrees so that the angle through which it will be changing, it is from 0 to 180 degree. Okay, so the vertical angle measurement, it can vary from 0 to 180 degree, while the horizontal angle measurement, it can vary from 0 to 360 degree. Okay, then these are the different adjustments of the theodolite. Similar to in the leveling you are seeing, there are the temporary adjustment as well as the permanent adjustment. Likewise, here also there are the temporary adjustments are there. So coming to the temporary adjustment, these are the temporary adjustment. The leveling screws, it should be at the center. Then shifting, it should be at the center. Then there are some nuts to adjust the tripod like that. So actually this temporary adjustment, you need not to focus. You should come to the, okay, so before setting up the instrument, temporary adjustments are to be run. Actually, there are two types of instrument adjustments, permanent adjustment and there is the temporary adjustment. Okay, so temporary adjustment, it is done by means of these three steps. So what is the first step? After doing the temporary adjustment, we have to go to the setting of the theodolite. Okay, so actually we are doing simultaneously. The theodolite will be fixed on the field at that particular position on which you have to set up. Along with that, you have to do the temporary adjustment also. Okay, so what are the different temporary adjustments you have to do? First, the leveling screws. What is the purpose of the leveling screws? To level the instrument. So you should have viewed onto the leveling bubble such that the bubble, it is at the center of the bubble tube. Okay, and this bubble centering, it should be done always when the telescope it is rotated in the full 360 degree. This theodolite bubble should be showing center position itself. Okay. Similarly, the second one, it is shifting the head of the theodolite at its center so that equal movement is possible in the direction. And similarly, actually this we are not noting, only thing the centering, that point at which we are getting centered, that's on the field. It should be just above that point, that's all. Then third, there is the leveling screws, the tripod legs. Okay, leveling screws we already seen. Third one, it is the tripod legs. So what do you mean by tripod? You already know. It is a stand on which it is placed. It is a, here you can see a picture. Okay, there was one picture. Okay, so this will be like this. This is your theodolite placed on the stand. So this theodolite stand, it is called the tripod. Okay, so actually the theodolite will be taken out of the box casing and placed on this tripod. So only thing, you have to place a tripod such that it is almost level. Okay, so that leveling you can do by means of the tripod legs itself. These three legs, you can see three legs. This is the first leg, second leg, and there is a third leg. It's like stand only. Okay, so using these three legs, you can adjust the position of these legs. You can move horizontally and vertically or like that, such that you can see the theodolite and the horizontal circle approximately in the horizontal direction. Okay, so usually this temporary adjustments, it should be done along with the setting itself. And the other thing is the centering. Okay, leveling, then centering is the setting up and centering. So what do you mean by centering? Centering means fixing your instrument on the point on which you have to place the instrument. That's all. So what you're doing actually, normally what you're done is that there will be the center point of this horizontal plate. From this you'll be dropping a stone, and what is the point at which you are, that point at which the stone is getting dropped down, that will be the point center of the instrument. Okay, So actually what you have to do, you will be you'll be to fix that instrument on a particular point on the field. For example, if there is a point here, you'll have to place this instrument on this point such that the center point of this horizontal plate is on above the point on the field. Okay, so that is one of the step that is required for centering. So that it is detailed here. Okay, so the different centering and level fixing process it is given here. So actually what we are doing here, there is a centering, leveling, and the third one there is the focusing the screws, focusing the eyepiece. Okay, so before that let me explain this. Here this is your bubble tube and here is the three screws. These are the foot screws you have already have along with your plate, horizontal plate, along with the telescope. So this three screws will be taken and there is your bubble plate or bubble tube also. So what we are doing is that you are rotating such that this bubble tube it is parallel to the direction of the axis of, or we can see we'll be making parallel to these two screws. Okay, this bubble tube will be made parallel to these two screws first of all, and you'll have to rotate these two screws itself clockwise or anti-clockwise. Okay, you'll have to rotate the screws clockwise or anti-clockwise until you are getting the bubble inside at the center. So this is the first process. Then second process is shown in the picture B. You are turning this bubble tube in the vertical, that is will be rotating the telescope again such that this plate it is brought in the perpendicular direction. This was your initial direction of the bubble tube, and the second picture it is made perpendicular to this direction, so that now the bubble tube is perpendicular to the direction of these two screws. Okay. So what were the two screws? A and B we have already seen. That are the two screws for which we have to concentrate now also. Again, with respect to these two screws, we'll be making this bubble tube perpendicular. And now at this position, this bubble inside, it may not be at the center. And you have to bring this to the center by means of the third screw. Okay. So here, in the first position, we are using these two screws. Clockwise or anti-clockwise rotation, it is done for the two screws. And until this bubble is brought to the center position. And in the next, the bubble tube, it is made perpendicular. And using the third screw, again, the bubble tube, it is made to the center. Okay. So this is the leveling by means of the three foot screws. So this is the accurate leveling. So before that, you have to do the leg adjustment. Using your tripod legs, you will be approximately centering the instrument. So on viewing itself, you will be able to make out whether the top of that plate it is horizontal or it is some toward inverted like that. Okay. So if there's some inclination is there, you can adjust by means of the tripod legs. After that, you will have to do the foot screw adjustment. And now next one, it is your focusing. Can you see here? The third process it is the focusing. So what are we are seeing? There is a leveling, centering. Along with that, after these two, we can do the focusing. So focusing means what you are doing is that you are bringing your object within the sight of this telescope. Okay. For example, you will be having some point A, B, like that. You will have to measure the angle between, and your instrument station will be at point O like that. Okay. Okay. So you can see this picture, I think. So here, what is that? This is your instrument station. Okay. So here B is the instrument station, and there are the points A and C. So setting the instrument at B, what you're doing is that you have to sight at point A as well as point C, and you'll be getting what is the angle between. Okay. So before measuring this angle, you have to do the focusing. Okay. So actually focusing means what you're doing is that from this instrument placed at the point B, that is once the instrument it is placed at the instrument station, you have to view through the telescope. Okay, you'll be having your telescope here, and there is a point already marked by means of some ranging rod. Okay, at point A, some ranging rod will be placed vertically, and we'll have to sight through that telescope, and you should be able to view that point A ranging rod. The ranging rod placed on the point A will be viewed through the telescope. Okay, so before viewing, you should be made clear the eyepiece and objective. It's like lens. Lens you already know. There will be some focusing points. So that focusing is done in these two steps. Focusing the eyepiece and focusing the objective. Two processes are there. Okay. So what do you mean by focusing the eyepiece? Focusing the eyepiece means in you already know within the telescope some crosshairs will be there. Okay. If you don't know, just make it that within the telescope, two crosshairs will be there. At least two crosshairs will be there. There will be the horizontal crosshair and there will be the vertical crosshair. Okay, it's like two lines. That's all. And now, when you're focusing the eyepiece, you'll be able to see that eyepiece hairs. That's all. Okay. So what you're doing here, it is a telescope. It is placed towards a white paper. White sheet will be placed in front of the telescope, and you will be viewing through that eyepiece. Okay, and moving that eyepiece in the horizontal and the clockwise or anti-clockwise. You can move it inwards or outwards until that crosshairs are visible. Okay, so first of all, make the crosshairs clear. Make it clear by means of your eyepiece adjustment. Okay, that is focusing the eyepiece. The next it is the focusing the objective. So where is your objective or where is your eyepiece? I already told. You can get some picture. Okay, I think we can explain with this here. This is your telescope. Actually, it is placed in the vertical. Okay, so move to this picture. So can you see this telescope here? This is your telescope. It's similar to this Theodolite only. This is your telescope. And here you can see this is your eyepiece. Okay, some lens will be inside. So through this, we will be viewing through. So what is the lens inside this position? That's called your eyepiece. And similar lens will be placed at here also. That is your objective lens. Okay. So this is the eyepiece lens and this is the object lens. So for making the clear vision of the eyepiece through the eyepiece, what you're doing, the crosshairs are made visible by just rotating this. It's like screw. You can see this is like screw. You can adjust. You can rotate the clockwise. It's clockwise rotation or anti-clockwise rotation can be given until whatever the crosshair you are seeing when you are viewing through, it is visible. That is the focusing of the eyepiece. So that is the first step within the focusing. So after that, you have to focus the objective. So focusing the objective, what you're doing is that your object will be made visible. Okay. So I had told this is the position of your object lens or this is the objective, and there will be some ranging rod to which you have to side. So again, what you're doing is that the focusing screw, some focusing screw will be there. Adjusting that, we can make visible when we are sighting through this within the along with the crosshair, you will be see that ranging rod also. Okay, so there's a process of focusing the objective. Okay. So focusing the objective, it's done by means of the focusing screw. It's a screw only. Okay, there will be the focusing screw, and focusing the eyepiece, it's just by rotating that circle that is placed near the eyepiece. Okay. And now, what are the different adjustments we have already done? It is leveling, centering, and focusing. Along with that, now our instrument is ready for sighting with the first object sighted already. Okay, and now next I'll be explaining how we are measuring an angle. Okay, so for today's class, we can see just measurement of horizontal angle only. Okay, so up to now, what are the different main parts of the theodolite we have seen? And coming to this slide, here I have already explained these are the 2 points A and C. We look on to the first picture. These are the points A and C at which you can imagine two ranging rods are placed. And what is this point B? Point B, it is your instrument station. Means it is a point on which you have placed your instrument. Theodolite instrument has been placed. Okay. So now what you're doing is that, okay, so measuring the angle, what you're doing, I can just tell. Setting the instrument at the point B, you are making your two verniers. I have told there are two verniers. There is a A vernier and there is a B vernier. Okay. We have already seen two plates are the upper plate and lower plate. And there are the two screws, two set of screws are the, which are the two screws? There is the main screw and the vernier screw. So corresponding to the upper plate, there will be the two screws. Similarly, corresponding to the lower plate, there will be the two screws. Similarly, for the vertical measurement, vertical circle also, there will be pair of screws. Okay, and along with that, there are two verniers. What is this vernier? We have already seen that picture, that slit through which we can measure the angle. That is a vernier. Okay, so there are two verniers, A and B. So what you're doing here is that when you're sighting to the point A, the angle reading on that point A vernier, when you're sighting to the point A, setting that instrument at the point B, your angle on the A vernier should be 0. Okay. So how to make out that angle 0? That is by moving your upper plate and lower plate. That's all. Okay. So for the first point on which when you're sighting to the first point, your angle on the A vernier should be 0. And now you can rotate clockwise until you are visible the next point C. Until your second point C, it is visible. And now what you're doing here is that I told there are two plates and you can actually you can move the upper plate or the lower plate. Okay, just note down there are two plates, upper plate and lower plate, and when you are moving the upper plate, at this moment it can be done by means of your upper screw, upper main screw and the upper plate tangential screw. Okay, so using the adjustment of the verniers on the upper plate, the angle on the vernier, angle on the A vernier as well as the B vernier can be changed. While if you are tightening the upper plate and losing the lower plate, that means if we are tightening the upper plate means the upper plate and lower plate, it is tightened together. Okay, so if we are fixing the upper plate and lower plate together, now we are again rotating the telescope. At this position, we can say the measurement on A or B vernier, it will not be changing. Are you getting? So that is, if you are loosening the upper plate by means of your upper screws, the angle will be changing. And if you are tightening the upper plate by means of your upper screws, the angle will not be changing. Okay, so this change of angle is the change I have told when we are rotating the telescope. Okay, so is it made clear? I think when you are rotating, when you fix the upper screw and the upper tangential screw, the angle will not be changing. And in the other case, if it is not tightened, the angle will be changing. Okay. So first, at the first instant, what you're doing here, you're placing the instrument at the point B. and sighting to the point A, at this position, the angle on the A vernier should be 0. So how we are making this? You have to make that. You have to lose your upper plate by means of your upper screws. You have to use your main screw and tangential screw and bring that vernier reading to 0 first of all. Okay, and then losing the bottom plate side to the point A. So when you're sighting, now we can see the angular reading on the A vernier or B vernier will be 0 degree only. Okay, and now we have to rotate the telescope until we are viewing the point C. Okay. So here, so what we have done here, once the instrument is set up at the point B, okay, once the instrument is set up at the point B, we are sighting to the point A, at which, what is the angular reading now on the two verniers? It will be 0 only. Okay, and now again rotate the telescope in the clockwise or anti-clockwise. Here, when we have to view to the point C, we'll have to rotate towards the right, and that again it depends upon the phase. Okay, so for time being, I'm telling we are rotating in the clockwise direction and sighting to the point C. And now, which is a screw, which is a upper screw or it is a bottom screw, we have to loosen now, because we should know the angle measurement change. From A to C, what is the angular change we are noting here? Okay, so for that, we'll have to lose the upper plate. And how we are losing the upper plate? Using the upper vernier and upper main screw. Okay, so correspondingly, we are rotating and sighting to the point C. Again, you are noting what is the angular readings. So what will be the angular readings on the verniers A and B? That will be the angle A, B, C. Okay, that will be the angle included between A and C at the point B, because at the A, when sighting to the point A, we have already set the angular value at A as 0 degree. So from 0, when you're reaching the point C, the angle, what is the change in angle? That will be what is the angle measured at the point C, that's all. Okay. So that is the angular measurement. And in the next class, by getting a video with respect to how we are measuring, again, I have got some videos from the online. I think we can upload that. So going through that, it will be more clear. Okay. So what you're doing here, it is the measurement of the horizontal angle, the angle included between the 2 points. It is measured by means of the upper plate as well as the lower plate movement. So this upper plate and lower plate movement, it is done by means of the two pair of screws, which are the upper plate screws and the lower plate screws. Okay, so that complete methodology, it is explained here. And now just come out two methods are the repetition method and there is the reiteration method. Okay, angular measurement, angle within 2 points that is made with respect to your instrument station. It can be measured by 2 methods. First method, it is the repetition method, and second method, it is the reiteration method. Okay, so what you're getting from this name, repetition. Repetition means it is getting repeated. Okay, so just remember what you have done here. When you are making the angle at the vernier, when you're setting to the point A, your angular reading on the vernier A, it is made 0, and then you're setting to the next point, and correspondingly when you're reading the horizontal angle on that vernier A, it will be giving what is the angle included between these 2 points A and C. Okay, the angle A, B, C will be got. And In the repetition method, what you're doing is that this angular measurement, it is repeated. Okay, this angular measurement will be repeated. Okay, the procedure it is written here. Okay, repetition method is not written. Okay. Okay, so just I'll be telling that repetition method. So just come to your initial position with the instrument positioned at the point B. We are sighted to the point A. And at this position, what is the vernier reading it is? At the initial position, what is the vernier reading it is? 0. On the vernier A, when you are sighting to the point A, the vernier reading you are made already 0. Okay, so that 0 you are making. You have to adjust the two screws and move the upper plate over the lower plate such that what are the angle on the A vernier it is made 0. And rotating the upper plate. Okay, next you are sighting to the point, next point C. So here what you have done? You are rotating the upper plate, okay? Or using your upper screws, you are rotating to the point C. And now, what are the angles on the vernier? You will be noting the angle included between A and B. Sorry, A and C. A, B, C, that's the angle. Angle included between A and C with respect to the point B. And now, again rotate the telescope clockwise, but now you have to use your lower plate. Okay, you have to tighten the upper plate and loosen the lower plate and rotate clockwise. Rotate clockwise. And now, when you're reaching this point again, A, it is sighted. Okay, so what you've done? You were initially at the point sighted to the point B. From B to C, you are sighted along the direction of C. So now what is the angle? What will angle A or B? What will be the angle? That angle it is measured on that vernier. And when you are losing your lower plate and rotating the telescope, the angle measurement will not be changing in this rotation. Okay, whatever be the angle you are getting here, that same angle will be maintained up to the telescope again sighted to the point A. Okay, so now the angle, what is the angle? Whatever be the angle you have measured as the angle ABC, the same angular measurement will be seen in the verniers. And now, from this position, so now the telescope it is directed towards the point A. Now you have to direct the telescope towards the point C, again to the next point C. So what you're doing here is that again the upper plate is loosened. So what you're doing, when the upper plate is loosened, the angular measurement will be changing and that angle will be approximately twice. Whatever be the angle that is already got in the first rotation, the twice of that angle will be seen in this position because we have rotated twice. Through this angle, we have rotated the telescope twice. Okay, so now the angle is 2 into the angle ABC. Whatever be the angle you are viewing on that vernier will be 2 into angle ABC. Similarly, you are repeating this once more. So totally 3 rotations are given. That means thrice we are measuring the angles. Angular changing, it is done thrice. So after the third rotation, what you are getting from the vernier, that will be 3 into whatever be the exact angle. So actually, what is the purpose of this repetition? Actually, what is the repetition process done here? That is to avoid the error. If you are made some error in the one step, in the next step that can be get distributed. And likewise, usually you will be giving 3 rotations. Okay, so take the average, that is your angle AOB. That is the repetition method. Okay, I think it's made clear. And now, okay, so coming to the reiteration method, it is similar process. The reiteration means up to now we have seen we are measuring one single angle in between 2 points. The angle included between 2 points we have measured just now. Okay. In the regression method, we'll be given 4 or 5 points and we'll be able to measure the angle included between each of the points. Okay. So that is by means of the regression method. I know some pictures refer to that. Okay, so the next comment is a repetition regression method. So just I'm explaining on this itself. Okay, so just imagine here this is your instrument station. Okay, then 2 points already are there, A and C, whose angle between you have to find out. There is another point, next points are there likewise, point C, D, like that. Okay, so you have to measure what is the angle between A and C, the next between C and D, the next between D and E, like that. So that means you have to measure the horizontal angle between number of points. So in such a case, we'll be using the reiteration method. Okay. So actually the reiteration method, it is useful for the point where if only single angle is to be measured, usually we will not be using a reiteration method. It's better if the points are getting distributed on a full horizontal circle. Okay, so what is the purpose of the reiteration method is that the error within a particular angle can be distributed. That is, if we are starting from a point A, first of all, we'll be sighting to the point A with the angle at the point A, it is 0, and we are rotating full clockwise rotation, it is given. And again, if it is reaching the point A, now the angular reading should be 360-degree. Okay, so I am here telling about the case of the upper plate lucet, that's all. Okay, that means angle value will be changing that case. So when you are starting from the point A, with at the point A it was 0-degree, we are rotating clockwise. Okay, we are rotating clockwise and again reaching the point A, it should be completing a full circle. And what is the exact angle now should be 360-degree. Okay, and if it is not 360-degree exactly on that vernier reading, that means you have made some error in between the angular measurement, some error has been occurred. So that check can be done by means of the reiteration method. Okay, so what you're doing is that actually what are the angle included in between each of this. For example, 5 angles are there. Finally, you are closing to the point A. Okay, so now you have measured 5 angles. Closing to that, the total angle should be 360-degree. And if it is not 360-degree, means whatever that angle through which it is not getting to 360-degree, that value is the error. So that error is to be distributed to each of the angles. Okay, so that is your reiteration method. Okay, so I think with that we can wind up here. So actually what we have, okay, just stop presenting.